Hey everyone, we are going to continue with our discussion on arrays and kind of pick up where we left off with the last video. Um, and so we covered a lot of the basics already. Some of the things that we did not cover um, is when you have a short list of items um, to initialize, you can use a shorthand notation. And I say a short number of items because um, you're probably not going to manually type in 100 values here. But if we want to create an array, and we'll just call this array called values, the shorthand notation to give um, all these subscripts values or data in them. So we just type in some numbers here. Okay, and this is the syntax for essentially a shorthand initialization for your arrays. So that's the first thing I wanted to talk about. Of course, if you want to say a string array called names, Bill, Bert, and Bob. And you can see here, if you were to do a system out print line, wait for my machine to catch up here, names sub 0, this one would be Bill, and this one would be Bert. If we go ahead and run, you can see the output. If we do a system out print line values sub, this would be 0, 1, 2, 3, should be 156. So you see how that works. So that's nice. That's a nice feature. Um, nice shorthand since arrays are so common and they're used everywhere. Um, it's nice to be able to work with them in that fashion. This was 156. Another thing is some alternate ways you can declare arrays. For example, every time if I said double, we're declaring a double called uh, my numbers and your numbers. In this scenario, both my numbers and your numbers are arrays. Both of these are arrays. Versus if I said double, and we'll just call it nums1, comma, nums, we'll just say num2. Well, this is, again, these are different ways to declare arrays. In this scenario above, both of these structures are arrays and they can hold a bunch of values, whereas this one, only the first element here, this would be an array, whereas num2 is a regular double. You couldn't store a bunch of different values in it. It could only hold one value at a time. So just a slight difference in how you can declare your arrays. You can now that we've worked on declaring and initializing arrays and all the different ways you can do that, what we're going to work on next, let me document this one here. This is nums1 is an array. Num2 is a primitive double. So the next thing, is once you have data in these arrays, in this scenario we have numbers, in this one we have names, we need to be able to work with those values. So what if, all of these numbers represented something and we needed to do math on them, where we would say, use them in an equation, something to the extent of, maybe our pay is equal to values, and for whatever reason this person makes $23 an hour or whatever it may be, you would say values sub zero, and you could use that in an equation. So 23 times 2, if you worked 2 hours and you're making 23 bucks an hour, and then we did system out print line, you would see the result of that math. So we said 23 times 2, which is 46. So that's coming out correctly. So you can use them in equations. Yay, we can use them in equations. We can also use them with the prefix and postfix operators. For example, system out print line values sub 0, and we're going to say plus plus, right? So we're going to increment value sub 0 by 1. So you can see that we took 23, we incremented by 1, and it would work, the same way with increment and decrement operators, prefix and postfix. So we've talked about that and how that can be useful, especially in your loops and things of that nature. So can be used with increment and decrement, prefix and postfix operators. Next thing is we can use them in both our conditional statements and our loops. So we could say if values sub 0 is greater than values sub 1, and going here, that is not true, right? So value sub 0 is not greater than, we can do something else. System out print line not true. Values at position 0 is greater than values at position 1. And in this scenario, this is the winner, so the next output should be not true. Very good. So we can use them in conditionals. And they can be used in loops. And I'll say while value sub 0 is not equal to 20, system out print line value sub 0 and values, and then we're going to decrement it, right? Because it was 23. I think we took it up to 24. Now we're going to decrement our control variable. So this is going to loop us several times and give us some output counting down to 20. So 24, 23, 22, 21. 20 is equal to 20, so that stops the loop. So that's nice. Yesterday we did talk about the property, actually in Java, I believe it's a field. It's a public field called length, and the length field is a public property. It's a public, oh geez, is a public value uh, associated with race. And so just to demonstrate that, names has 1, 2, 3 values, so the length property should print out 3. And we did do that in our previous video, if you followed that one along. So I'll say the names array has names.length, and you could see it's directly accessible even though it's a field, it's public, so you can access it. Has 3 names in it. The names array has 3 names in it. Therefore, if I were to go up top and add Billy, so now you see it has 4 names in it, and if you add to it or change it in size, it adjusts automatically. This length field does. So it's a really nice thing. It's used quite a bit, especially in loops, to control the number of iterations a loop goes through. The length field is a commonly used field. Moving along, the next thing we want to talk about, since we just got done talking about loops, is a shorthand for loop. And this is really nice because we're always using arrays and we're always using loops. And so since we're always doing these things, why not get comfortable with a shorthand notation? And so we'll go ahead and use our values array that we declared up top. And if you notice, we got 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 numbers in there. And so the shorthand for, and we declare our control variable int, and we'll just say val inside of our values array. Now this isn't, values is our array, so that's the important part to read right here. Values is our array, and val is actually going to be the variable that holds each position's value, and you'll see what I mean by that. You can call this whatever you like. I'm going to call it, just to demonstrate something, it's a little weird to me to say int val in values, so I'm just going to call this, for the purpose of this demonstration, I'm just going to call this a Sonic, whatever, it doesn't really matter, right, is the point here. And I'm just going to do a system out print line. I'm going to print out Sonic, and again, that's our variable, and each iteration through the loop, it's going to hold, the first time through this shorthand for loop, it's Sonic will hold 23. The next time through, it'll hold 645. The third iteration through, it'll hold this number here, etc., 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 all the way, and basically loop through every element in this array. Now that's the idea here behind the shorthand. You're not going to loop through every other element. You're looping through every element, and it's also a read-only loop. This is a read-only, meaning you can only read values out of an array. You can't put data into an array using this shorthand loop. If you're going to put data into an array using a loop, just use a regular for loop that we covered already in the previous video. So just to demonstrate this is a read-only loop, and this is going to print out all of our numbers all the way up to 447, which was our last number. And so it's a shorthand. I do recommend getting used to this. You're going to write enough for loops, and you're going to use enough with arrays. It's in your best interest to get familiar with this shorthand. Looking into what I want to demonstrate next. how we're doing on time. Actually, we're at a good stopping point for today. So thanks for following along, and we'll pick back up next time. Thank you. Bye.